Hello, everyone. Welcome back to Advent of Code. It's day 9 today. We're going to be working on day 9 of course, 2023. I have just a small update to the day 8 solution here, which I've already got on the screen. This part 2 thing was rather unwieldy. I think I have like 2 different commits improving this, but you're just seeing the diff of them added together. Basically, like, this was a rather long, lengthy thing, and starts was not that useful name. So instead, what I do is I turned the whole thing into just a composition of functions applied to M and extracted the most meaningful function I could think of to be in a where binding, so that the thing fits kind of in one digestible, understandable line, and then you can look up the details of what loop length is on the next line. So I don't know. I think this is better than what I had before, but obviously it's just like surface prettiness. It's not like any big semantic difference. Okay, so let's move on then to day 9. Day 9, mirage maintenance. You ride the camel through the sandstorm and stop where the ghost's maps told you to stop. Is that apostrophe in the right place? I guess so. It's not maps belonging to the ghosts who haunt the sandy area, the desert in general. It's the maps belonging to the ghost of that elf who gave you the maps. Okay, fine. The sandstorm subsequently subsides, somehow seeing you standing at an oasis. That's a rather rude little... It's not quite a tongue twister, I mean, kind of, but it's very alliterative anyway. The camel goes to get some water and you stretch your neck. As you look up, you discover what must be yet another giant floating island. This one made of metal. That must be where the parts to fix the sand machines come from. There's even a hang glider partially buried in the sand here. Once the sun rises and heats up the sand, you might be able to use the glider and the hot air to get all the way up to the metal island. While you wait for the sun to rise, you admire the oasis hidden here in the middle of Desert Island. It must have a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone, so the oasis can be around for the next sandstorm-worn traveler. You pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis produces a report of many values and how they are changing over time, your puzzle input. Each line in the report contains the history of a single value. For example, yes, sure. So this is the history of something. It's going up by 3 every year. This is the triangular numbers. What the heck is this? Eh? Are these... No, they're not Fibonacci numbers. What are these? I assume because these first 2 rows are so regular. Yeah, okay. So maybe our puzzle is going to be like finding the line like this one that's a little bit weird and isn't following some obvious regular progression. To best protect the oasis, your environmental report should include a prediction of the next value in each history. Or is it just going to be a quadratic thing, maybe? To do this, start by making a new sequence from the difference at each step of your history. If that sequence is not all zeros, do so again, using the sequence you just generated as the input sequence. Once all the values in your latest sequence are zeros, you can extrapolate what the next value of the original history should be. Yes. So this is actually a generic, polynomial fitting, basically. This is a technique to fit a polynomial to any sequence of data points. And it's very easy to do as long as you don't care what the degree of the polynomial is. The problem is that, this isn't really... I don't know. 6 mostly unrelated values you can fit a 7th degree or a 6th degree polynomial to them, of course, but it's you're gonna get something completely wacky out as the 7th answer. Now, since these are actually described by a straight line, you will get a very good polynomial. It'll just be a straight line. This should be a parabola, right? Sort of. One difference of 2, 3, 4, 5, 6. I mean, yeah. The triangular numbers are described by a parabola of some kind. There's a difference of 3, 3, 5, 9, 15. And you do that sequence again. You get a difference of 0 to... I don't know. But they'll show us an example. Sequence of differences is all 3s. It has fewer values, yes. Repeat it again until you get all 0s. Now you extrapolate by adding a new 0 to the end. Yes. A, B? Sure, fill in the placeholders by put a 3 here. Yeah. Yeah. Now what about the last one? It looked kind of gross. 0, 2, 4, 6, 8. Okay. Yeah, all right. I mean, there's got to be some very pretty way to do this, right? I mean, the first thing is maybe someone's just written a library out there for polynomial fitting, and we can just use that because that's what we're doing. But probably that's not the best approach. Maybe it would even have rounding errors. Who knows? Obviously, turning like it's so hard to highlight stuff when like the word wrap highlights the whole thing for some reason. Anyway, it's very easy to turn this into this in Haskell. Super, super easy. And we can iterate that and get a sequence of the reductions and stop when we get all 0s. I mean, that's very simple. Applying that back in reverse to get the last number, I mean, it can't be that hard, right? But let's see. Actually, let's get my input real quick. And see what it looks like. Not this input. What am I doing in day 8? Oh, it's because... Okay, fine. Negative numbers. How exciting. Okay. So we have 200 rows, it would seem. And some of these numbers are very large. Sure. So I was claiming that it's very simple to write a function. I guess we'll do it here. That gives us back a list of the distillations of a sequence, I guess. So let's say we write distill is a function from a list of int to a list of int. Distill, 2 L's in that, right? I think so. Zip with minus, right? A minus, yeah. Actually, I think I might want to zip with subtract. The order is better. Does that type check? It does type check. It might be backwards, but let's see. Distill of 0, 3 up to 15, which is the example question. Yeah, perfect. That's correct. I don't know if we even want distill to be a named function. It's so simple. But this function obviously could use some clarification to someone who's not used to this little pattern in Haskell. We've already talked in several previous episodes about using the applicative and I guess technically monad instance for functions, but usually just the applicative instance for functions. Right? If we look at what is f app x in the function monad, well, let's actually call this a. F app a is a function taking x, because we're working on the function applicative, to apply f to x and then apply that to a. Sorry, not f of x. Yeah. And actually it's this, right? Yeah. So it's to apply x to both of these things and then get the result, and then apply the first one, which is a function, to the second. And so if you just expand this out, we can say zip with subtract tail, app tail rather. We'll write it like this. Equals lambda x to zip with subtract x, tail x, which is what is zip with subtract? I mean, subtract is basically lambda of a and b to b minus a. Because subtract, you're supposed to use this as a partial, so you say subtract 5, like that's a function that subtracts 5 from something, which means it's the second argument to minus. So zip with, well, I guess let's write it like that first. Where did my x go? And now it's sort of starting to look like an actual normal application of zip with, right? We take a list, x, let's actually change the variable name to x's, and zip that list x's with its own tail, i.e. dropping the first element, and to each pair we apply the function subtract the first number from the second. And so that gives us like, oh, of course, how nice. It's the successive differences, I'm not sure quite what the right word for that is, of the function. So, I don't know. I always like playing around with the applicative instance for function. It doesn't always make the most readable code, but it does make short code, and it kind of lets you helps you appreciate the beauty of applicatives and their pervasiveness throughout all kinds of data structures that you can. There's all these useful built-ins that you don't have to write for a million different types because they're defined for functor or applicative or monad or whatever. And a bunch of types do inhabit those type classes. So you get a reusable library for writing cool stuff. Okay, so that's distill, right? And we could write, solve, maybe. Is a function from list of int to list of int, where solve is just well, I guess we could write take while any not equal 0, iterate distill, right? Doesn't quite compile. Oh, I need to say, no? Oh, yes. If I read the error message, it would tell me, oh, not equals applied to too many arguments. I forgot those. So now if we were to write solve of this, it would say, here's the original list, and then all 3s. Now, we don't get the list that's all 0s, but that's okay. Because we know that the last one will be all 0s, right? So we can just, like, add a 3 to the end of this list, or indeed even the start, if we wanted. So the question is how to apply the end of this list, right, to we've done the inference, I guess you could say. Now we need to do the extrapolation. We've inferred that there should be another 3 at the end of this list, and that should cause the first list to get a new element that's 3 higher. But how do we actually do that? The funny thing, I guess, is, well, hang on. Can we just do this as a pairwise thing, kind of? I was thinking about, there's some special logic to do at the end of the list, right? It's saying, add in this extra 0, and then add something here, and then add something here. But the point, I guess, is that this list, in its entirety, no, is sort of derived from this one. Is that true? Because if we took this element and lined them up, we should get this element, right? And if we took this element and lined them up, we should get this element. That's true in all of these, right? That's the point of all this. These two yield this. These two yield this. This is like Pascal's triangle shit, right? Any V shape I draw, the construction of this diagram is that the top left and the bottom middle add to the top right. So we have a blank space here, and we'll need to add something to it. But So I guess if we add a 0, if we actually, we kind of want this zeros list, right? I mean, technically we don't need it, but it would let us do everything in a more uniform way. It's a little annoying. Why? Drop while and take while are both not really what I want. Which I guess means I'm supposed to want break or span, right? Which of those is it again? We used that just last episode, and I can't remember which is which. They're all the fucking same. I think it's break, right? Break. Applied to a predicate P in a list of X's, returns a tuple of first element is the longest prefix that do not satisfy, and second element is the remainder of the list, which we will assume at least one of them does, but in principle there could be no hits if, like, math didn't work. So we'll be ignoring an inexhaustive pattern match warning today, I think. So really, I don't want solve, or I do want solve, but it needs to be implemented not with take while. Case break x's of seeks zeros. Zeros has an E, right? Yeah. Then it's, something. And anything else, it's like error, math is broken. Like this can't happen. And we basically just want to return like seeks and then add in zeros at the end, right? Which is a rather ugly operation to do. Actually, I kind of want to reverse this, don't I? I want 0 cons to... Well, no, I want... See, you want... You want to process the list from the bottom up, which, since we're using singly linked lists, means we want the bottom of the tree first, which means we want zeros first, right? So we kind of want zeros and reverse seeks, right? And I guess I won't add in the extra 0 yet. Yeah, that's not something solve should do. So we want zeros reverse seeks. Now this is an inefficient operation, but like it's a small data set, who cares? So let's reload this and let's solve one of the other inputs. The final example they give us, the most complicated one, would be this, but with commas. Uh-oh. Oh. Because I wrote break, this should be all equal 0. I inverted the meaning of something. Yeah. So now we get 0, 0, 2, 2, 2, 0, 2, 4, 6, 3, 3, 5, 9, 15, and the original list. Perfect. That's exactly the triangle we're supposed to have in the order that we'd like to process it. So the next process looks almost like a fold. I'm not sure if it actually is one, but it might be. Right? Because at each step, I want to combine these two, getting some new thing, and that new thing is going to be a list of 4 2s, and then I want to combine that with this, right? So I have, by combining these two, I've gotten an accumulator, like a new accumulator value, and I want to combine it with this, I think. And then I want to combine the result of that with this, and so on. And that looks an awful lot like a fold L. But I'm always nervous about fold L. It's great in strict language, and it's usually bad in Haskell. Could I have left 0, 0 at the end and not reversed the input and done it with a fold R somehow? Maybe. Now, something about this still feels a little bit off. I had this idea of like, okay, yeah, let's zip this and this together, and we get that, and that's fine. You know, zip this and this together, we get this. Zip this and this together, and we get this. But how is it that I'm zipping together two lists of length 3 and I think I'm getting a list of length 4 as a result? Like, that's not how zipping works. So I must be somewhat confused. Right? I mean, it's not really is it even a zip? Zipping these like, if you shifted this list left a little bit, you'd have a way to produce this one digit. But not with a zip, because like really you would just say, okay, let's add this number and this number together, and that's what goes here. All the faffing about with these 4 elements is just like for the sake of beauty, for noticing that that's how that that identity still happens to hold. It's not learning anything new, and we already know what items go there. We don't need to recompute them. It just would be kind of nice if we could, like, well, so maybe the point is, well, I of course I see how I'm getting 4 elements. I'm getting these 3 by this series of 3 additions that I'm describing. This one, we're going to have to borrow from the original input sequence. So we're going to take, like, the head of the top row, and then zip together the top row with the bottom row. And that gives us a new top row, entire top row, right? And a bunch of the elements in this are going to be like kind of, well, why did you bother computing this? You could have just looked it up in the original one. But I don't know, it seems kind of nice. And I don't know. I wonder if we don't actually need this whole span and break and make sure to keep the original sequence of zeros thing. Because if we're zipping stuff together, and I know the last row is a bunch of zeros, I can just write like repeat 0. Repeat 0. Or no, just a single repeat 0. And that would be a list of infinite zeros. And when I zip it with a list of length 3, it would give me a list of length 3. Plus the 2 that we're borrowing from the beginning of this sequence. So maybe this is a foldar where the initial value is repeat 0, and we actually process it from the top down, and just let GHC handle the fact that the top depends on this, which depends on this and this and this and so on. I think it might still have the issue that it's like could potentially blow the stack for very large inputs. Like, its strictness analysis is maybe not great, or strictness properties are not great. But obviously we have very small inputs, so that's not a problem. Yeah. Sure, I mean, that should be an interesting approach. Let's try it. So forget this solve with break shit. And go back to what I had a while ago, right? Which is literally just take while any not equal 0. Get rid of that case, please. And if we go back and reload this, solve still gives us the right answer, except it doesn't include the zeros at the end, and it's in the other order. And I think that, I mean, that's what I decided I want. We'll see whether I was right about whether that's what I want or not. But it's at least on purpose. So what we want then is like extrapolate, right? Takes a list of int and gives you back a list of int that's the final row. Maybe we should just give you back the int that's at the end, right? We can just compose last with that. Extrapolate is last composed with fold R of compose? Combine? Combine with repeat 0. So what type do you think combine should have? Should take 2 lists of ints and produce another list of int. I agree. Okay. Where combine of... We're going to need... Let's see, which one's first? The first one is the longer list. Well... They're both equally long once we're done, but okay. The first list is the one we need to find. Wait, is it? Oh, I know. I mean, foldr takes its accumulator argument second. What exactly is my accumulator here? Well, that means that it takes an element from the input list as its first argument, which means one that I haven't processed yet. So yeah, okay. So combine of empty and anything is error. Like, math is broken. We can't have an empty list. Combine of x's with y's is x const 2 zip with plus x, just x's or x const x's? X const x's. So actually what I should do is this. X is where we get out the first, x is y's, right? So this compiles. Does it do what I want? Okay, yeah, but I meant like apply it to this list, please. 68. That's the right number. Okay. Cool. I think I'm pretty happy. It would be quite a coincidence if we came up with add 23 just by random luck. So I think we can say that that's probably, oops, wrong window. That's probably correct. Now, obviously, like, all of this we could just, like, write as a single function composition. They're fairly short. I don't know. It's nice giving these things names, isn't it? So, okay, what we have to write a parser, I guess. We don't really need any types because we're just getting a list of int, and that's our whole input. Like, you barely even need regex applicative. And yet, I'm cursed to always use it because I just like it. Let me double check our input format real quick. Oh yeah, this whole negate thing, sure. So it'll be nice to use signed decimal from. Let me look up text regex applicative real quick, because I remember it has in common. Is it called signed? It is. Yes. Okay. Cool. So we'll want signed decimals. Yeah, I think we don't even really need it. I'll write this whole thing inline and prepare. There's really so little to do. Import text regex applicative. Do we even need RE? I think we can let that all be implied. We don't need to mention the type ever. Our input file has exactly one space between each of them. So I guess we need sim and match. And then from and we'll want like some, I guess. Text regex applicative common, we need signed and decimal. Decimal? Okay. Why did I write an M there? I don't know. Finger was on the M from earlier. Got bored, decided to contribute. So prepare is map maybe equal tilde to input composed with lines, where input is some I actually need set by, don't I? It's annoying. Signed decimal set by sim space, and set A set by B is, we've written this before, it's nothing fancy. I'm sure it looks like gibberish if you've never seen it, but I don't know. Tough luck. So we're gonna parse an A and cons that onto the result of parsing some B A like that. We need map maybe, import data maybe, map maybe. So let's just check that real quick. Length, well, I mean, okay. Prepare of read file input.txt, please. It's a bunch of junk, and if I say length composed with prepare, there's 200 lines, so it looks like it all parsed fine. Okay, great. So what are we supposed to do? Sum together all the extrapolated values? Yeah, so input to int. Part one is just sum.map extrapolate.solve.distill. Right? That's it? Great. Stack, run this baby, please. It's a number. Seems kind of large, doesn't it? But I guess our input values are very large, and as I said, fitting n-degree polynomials on sequences of n digits can get quite wacky. So let's try it. Too low. Oh, I said it was too large. Oh, dear. Okay. Well, sure. let's go debugging. Too low. Is it possible that what are some things I could imagine I might have messed up here? One is that this take while there's at least one non-zero. Yeah, that's correct. I didn't get that backwards and just have like a single line. So what if I... Okay. What if I just said... I'll test the small 3-line input they gave me earlier. The problem is defining that is a little annoying. So I guess let's just define test.text or something. Test.input.text. We'll paste that in there. And map. I'm going to basically implement part 1, right? I mean, I don't know. Why don't I just call part 1 over part 1.prepare over read file test.input.text. It says 33. Well, that's way wrong. If we look at the examples they gave me here, we get 18, 28, and 68, and we're supposed to add those together and get 114. Somehow I'm getting 33? It's not good news. Prepare of, well, okay. So what if I said map, we won't extrapolate, we'll just call solve composed with distill. What? Is this right? Something is wrong here. We're missing the beginning of... We're missing the first element of the list. Yeah, map distill is nuts. Isn't it? Something's wrong with distill. I thought we had it before. Distill of 0, 3 up to 15. That's... I think that's sort of right, except we just aren't keeping the first element of the list, I think is the problem. Like, why? Oh, yeah, that's true. So this little trick, it gets you 2 lists. Alright, maybe I'm gonna get rid of this. Distill X's is this when you zip a list with its own tail, you get back a list that's one shorter than you had before. Oh, wait a minute, isn't that's fine? That's what I wanted. Because this just gives you the next step in the sequence. So solve of... Oh, hang on, I learned how to copy paste in Tmux. Ah, okay. Solve that. Now this is correct, yes? Wait a minute. Solve already does the distilling. Okay, so you're not supposed to compose it here. It's just extrapolate and solve. Okay. Stack run again, please. I mean, I guess I might as well test that this works. Yeah, now we get 114. Okay. Let's paste this absolutely for certain winning bad boy right in there. That's the right answer. Gold star for me. Okay. So anything in here I don't like? I think it's all looking pretty cool. Distill, solve, and extrapolate might or might not go into part 1. I really have no guesses about what part 2 might be. What is this about? Oh, that's right. My template, somehow I accidentally put an extra blank line at the end of every file. Yes, commit that, please. Day 9, part 1. All right. Part 2. Of course, it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well. For each history, repeat the process to find differences till the sequence of differences is 0. Then, rather than adding a 0 at the end and filling in the next values, you should instead add a 0 to the beginning and then fill in new first values. And we're not filling in things on the right anymore, only on the left. Well, this is pretty easy, right? I can think of one way to do it, which is to just... Well, is it? I was thinking you could, like, reverse the list and negate some number somewhere and everything would come out okay? I'm not sure about that. I'm not sure exactly which numbers you're supposed to negate for that to happen. But yeah, can't you just reverse all the inputs? No, that's probably bad, isn't it? Maybe. Because this minus this, of course, would be minus 15. This would be minus 6. Minus 15... sorry, it would be minus 9. Minus 9 would be a normal 6. I don't know. Something seems very sketchy about that. Well, fine. Let's go review what we wrote. See. So this whole like solve thing is perfect. We're gonna want exactly solve again. Extrapolate. We just need a different version of extrapolate for part 2, right? And again, we just want last, fold our combine, repeat 0. But really, we just need a different combining function, I think, right? Because I want to take the last element of the list, jam it at the end. Yeah. I mean, this won't be the most efficient way to do it, I'm sure. But that's okay. So let's write, it takes a function from something to something. You tell me what in a minute, please. And produces this. We're going to take extrapolate f hold our combine f. Actually, it needs to be a 2-argument function, right? Actually, why don't I just say, here, it's a function of some type. Yeah, list of int to list of int to list of int. Fine, I guess I'll just write that in. I mean, gosh, this is... No, it's not a... Yeah, it doesn't matter. It's a function from int that takes two lists of ints and gives you another list of int back. And now combine can be a new top level thing. Or really can be part of part 1, right? So actually I should have left it like this. Yeah. And now if I rewrite this, stack run, not if I rewrite, if I save it, why did I say rewrite? I don't know. So this is the correct value. We haven't broken anything. Although solve is kind of I'd like a different name for that, maybe. Because I want part 1 to be like solve combine and part 2 to be solve of combine, but like it's a different combine. Wouldn't that be nice? I don't know. Sum.map extrapolate combine composed with solve is fine. So it's an int, and it's again sum map extrapolate combine solve, where combine of nothing is like, what the heck, man? It would be nice, by the way, to factor out these two equations from combine into extrapolate, or no, solve, where? Extrapolate. And then have part 1 and part 2 only take a non-empty list. But we don't, well, actually, why not? The issue is that, like, lists are, they can be empty. And even if you prove in one place that a list is not empty, and then you pass it to some other function, the type system doesn't guarantee that that list will be non-empty. And so you have, like, again, you have to check, oh, is this not empty? But, like, that's what data list not empty is for, right? Non-empty. Is that, do I have that? No. Capital E? Okay. I just want a few functions from this, please. Non-empty. Actually, I don't use non-empty very much. What functions are available here? Data, yeah, so it has, right, we have this. That's the constructor, of course. And it has all these type class instances. So this is the type of lists that are guaranteed to not be empty by the type system. And it's not some special blessed type that, like, GHC knows about and it can prove this on lists. It's, you could write non-empty yourself, and indeed somebody has just an ordinary library. And you do that by just, like, you don't expose a way to turn a list into a non-empty by creating a constructor like that. You give them a constructor that says, give me one item, and then a list of the rest of the items. That way they have to give you at least one item, and you know the list isn't empty. The tail of the list might be empty, so it's just an ordinary list. But the head is not. And it has all these nice, foldables. So you can call toList on it if you want, or you could... What's the type of last? It's lit. It's type of lists, okay. It has a call stack. That's interesting. They're working on adding call stacks to stuff, I guess, these days. That's nice. So that's what this constructor is. Basic functions, so it has, has all these things. Last, okay. So I guess we won't use the ones in foldable, although I'm a little surprised, actually, that foldable doesn't have something called last. I guess last composed with two lists would do it, right? So maybe we'll just write that instead of using the ones built into data list. They should be just as efficient, I would, or well, probably not, but efficient enough. So let's say all I want is non-empty, and we'll write. Yeah. So let's okay. We also, like, is there some, so digression here. A type exists called endo of A. Is an endo. It's just a function from A to A, like a way to modify a thing. I'm sure there must be a thing like this, like it's a bendo or a window or a by whatever, right? But I don't know what it is. Like if I look up endo, is it like bifunction or something? Like, I don't know. What types would it even have? I just thought it would be nice not to have to write out, non-empty int a million times, but all right, whatever. We're obviously not using endo here. I was just thinking of something sort of related. So instead of this, I want non-empty int. Yeah. To non-empty int and non-empty int. Now, where exactly am I going to actually convert these things from lists to non-empties? Actually, how do you call repeat and get a non-empty list back? Is building streams, iterate, repeat? Okay, there's one called repeat. Sure. So these, I think we want the inputs to be the same. We want this to just be a list of int because it's coming from solve. Fine. Import prelude hiding repeat, please. Go where go of takes two list events, and I need to convert each to non-empty. So go of this is error, math is quit. Go of this is quit as well. Actually, how do you convert? Let's go read the docs a little bit more. How are you meant to check whether a list is not empty and then like? Of course, not the way I'm doing it, you idiot. Okay, great. Just looking at the constructor, I'm like, oh yeah, right, great. So this is not what we're supposed to do. We should, instead of thinking in negative space about what are the types we want to forbid, we should first think about what's allowed. XX's, YY's is f of x x's and y, y's. And then anything else is an error. Right? And then we can just say combine of x's and y's, and I guess I want two lists of y's. Okay, so what are you trying to tell me here? Line 22, this one. Oh, well, I have repeat from non-empty. Oh, this actually should be the one from... because I'm doing the conversion elsewhere. Right? Line 20. Oh. The problem now is that Go is returning a non-empty list. But because that's what F is returning. But Foldar thinks it's working on just ordinary lists. So really, I guess what I should do is convert the list of int into a list of non-empty, list of non-empty int, right? So I actually want to put this back. Because this is the list, this is the accumulator, which I want to be non-empties. Oh, actually, is it just that I was supposed to do this? We're supposed to build a non-empty list? It's not, right? Yeah, because there was a type error in extrapolate. But this is correct. And what zip width do we have here? Yeah, x's is just a list, and two lists of y's is just a list. Okay, that's fine. So extrapolate should be map to non-empties, where two well, I guess just two non-empty, right? It's going to be called on a single list of int. Two non-empty of blah is error math is broken. Otherwise, x's is x's, right? Go doesn't exist anymore because I just deleted it like a weirdo. Yeah, go of... oh, I can just call F now, right? I already did all my conversions. So I wasn't a weirdo for deleting it, but okay. Getting closer, maybe? The error is on line 22. That's still this one. Type of repeat is data list not empty. Oh, are we upset with about last? Okay, there's several errors here. Okay, toList is not in scope. Sure, we can add that import, I guess, instead of taking the one from foldable. But what does this all mean? Okay, part 2 is like not finished yet, right? So that's fine. We can just do that. Now the errors fit on one screen. What's the type of folder? Takes foldables. Okay. It's not like the Prelude has some specialized folder that only works on lists. Although in this case, I think I do have a list of non-empties. Extrapolate, it doesn't... Why do you think there are these lists of ints that should be lying around? Oh, because I'm composing with last. I think. Yeah. It was trying to use the preludes last, which takes a list. And therefore assuming this folder should return a list somehow. And then it said, well, that can't be because you're giving me a non-empty when you should be giving me a list. Okay. Well, that was a bit more work than I would have liked. Is this... I guess I meant to say run, but I said build for some reason. Error. Math is broken. That's fair. I didn't implement part 2. There you go. Now it should run, yeah? Sure. And we still get the right answer. I like this. So let's commit the parts of it that I like and leave out part 2. Day 9, use non-empty to abstract extrapolate. There. Now that extrapolate is ready, we'll be passing it a non-empty list. And we can just... All our extrapolate needs is to be given a way to combine two lists, two non-empty lists, into another non-empty list. And it'll run the whole shebang for us, right? Now it's a little tricky because here we don't actually... Well... We don't care at all about the first element of the list anymore, right? Non-empties, they must be applicative, right? So monad zip even. Yes, they are applicative. They're monads too, which I guess makes sense, but I don't need it at the moment. And they're monoids and all this other good stuff, right? Where is monoid? There it is. Oh, I have it. Wait, what? Oh, I guess they're not. Because there is no empty element. But they should be semigroup, right? Yes, non-empties are semigroups. And that's all I need to be able to add an element to a list. Okay. So if I say combine of x's and y's, it's like I want to get like the last element of the list and all but the last element of the list. Like the tail view of it in a way. I guess that's last in a knit. Kind of gross. Prepend. Okay, so that's cons to the front, of course. Uncons. That's what I want. No? I want like uncons, of course, gives you the first element in a stream of the rest. Although, this is weird. Sure, whatever. Not really what I want. In knits. See back all the finite prefixes. No. Extracting sublists. Group? What the heck? Oh, I see. There's a function named group in Haskell that I don't use very much, and so I forgot what it is, but okay. Yeah, this is all not what I want, so I'll just use init and last. Let x and x's, well, okay. Be I'm gonna have to put that there too, of course. Last x's. Let's call this T and H just to confuse people. T is the tail, H is the head, but usually the tail is a whole list and the head is a single item, and this time it's the other way around. H is init x's in. Wait, do I actually need init x's? Yeah, because that's what I'm supposed to zip with y's, right? I don't know, something feels weird here. Also, I don't really have a proof that this is non-empty, do I? Because zipwith might return an empty thing. In this example, I was consing x to the front, and so I could say, yeah, it'll be non-empty. But I don't have a non-empty list to add an item to the front of this time. Is there a function that takes a list? I mean, oh God, not really, right? I guess I can just use non-empty, basically. Okay. Or call from list, which throws an error if it fails to match, which I guess is fine. Because I know it will never fail, because I'm going to be adding an element to it at some point. So zip with I want subtract again, right? Because I'm the row below is the delta. No, so I actually want minus the top row, which is the first thing, minus the bottom row. Zip with minus of x's and to list y's. But then we're going to append, oh, not x's, but h. We're going to append pure t. This should be from list. I don't know if this is correct. It type checks. Well, it's definitely wrong right now. Okay. Maybe now it could be correct. Let's run it. Well, no. Let's be a little more responsible than that, shall we? People could die if my code is wrong. Let's write part 2 on the input. It says 81. Do we think that would be correct? Doesn't sound right to me. It says the answer should be 2. Okay, good. I'm glad to see that my slapdash way of programming is being punished. God, what have I got wrong now? 2, huh? How did I get 81? The thing is, like, all the magic is happening in combine, so there's not really a lot of... Or it's being done in extrapolate. I guess what I could do... I was going to say I could test combine in isolation, but I've foolishly... Oh, sorry, you guys can't see this. I've foolishly made it a local function. Let's... For now... make it a top-level function. Yeah, and combine chat is the other one. I don't care. So what I want to know is, like, what happens if we call combine of, like, 1, 2, 3 with... What order does it take these in? The rightmost one should be the deltas, right? And so it should be one shorter than that. Let's just put some zeros in there. Does that work? It should give me 0, 1, 2, 3. Oh, combine takes non-empty. It just gave me back 1, 2, 3. Shouldn't the list have gotten longer? Good. Okay, so I found the problem of some sort. Because we're trying to extrapolate the value to the left of the original list, not just the original list, please. So why does part 1's combine work? Because don't each of them zip 2 shorter lists together and then add one element to one side? Huh. Oh, I think the problem is I passed in a bad input in my REPL testing. Because we assume that the 2 lists we're being given are the same size, and then we expand one of them. But this still doesn't work. Yeah, it gave me a non-empty. Why do I get 1, 2, 3 with no 0 on the front? I mean, it's pretty easy to do the substitution here. X's is... Oh, I didn't reload. Nope, still wrong. Oh, but of course there's nothing to reload, because I said my claim was that I passed it the wrong input. So in this case, if we say X's is 1, 2, 3, then T is 3 and H is 1, 2, right? Zip with minus. Yeah, I mean, obviously this only gives you a list of length 3. So why does this one give you a list of length 4 in that case? Is it possible that it doesn't? In this case, let's say X's were 1, 2, 3. Then X would be 1 and X's would be 2, 3. 1 cons to zipping 2, 3 with 2 lists of Y's. So this is the same length. How can that be? Oh, well, the point is... No. Is that the point? Extrapolate doesn't care about the whole list. We're just like calling last at the end. So maybe it was fine somehow that the front of the list didn't get longer or something? Oh, and toNonEmpty is, of course, just from list. So this f function is combine. And it gives us back. I think it must actually be dropping the first item of the input list accidentally somehow. But it's not. I mean, the first item is right here. That's it. And then it maps x's. Like, what? What am I missing? This is obviously giving back. A list the same size as the thing on the left. Which, I mean, what would that mean in this context? If I were here, if I got this, I combined it with this and I got back like 0246 or something. Well, wait a minute. Is this just stupid? A lot of things are stupid when I do them, but isn't this just like scanl plus? Like, why did I do all this work? Maybe it's not. No, it can't. Of course, you need... You need this item and this entire list to build this, right? Or to build this, let's say. You could do it by pairwise, like add these two together to get this, add these two together to get this. But you could also say, oh, just start here and like make a list that's the start of this and all of this, and then scanl plus them, right? And that would give you back a list of the right length. Yeah, that's just a way better solution to part 1. And I bet it scales better to part 2 somehow. So I think extrapolate is still fine. Right? It's giving you like some non-empties and saying, you figure it out, man. I don't want to touch them. And part 1 just needs a different combine function. Do I have anything important committed right now that I would hate to lose? Yeah, I mean, some more improvements to extrapolate, right? I simplified that and added some more imports, I guess. Sure. Day 9, part 2. Simplify. Extrapolate. Okay. So I can get back to that if I screw things up. a point where things are compiling but not working. So I kind of want combine like to look like this, I think. Or I don't even care about anything but the first element of x's, in fact. And I want it to be... I bet scanl needs to come from here as well. Where am I? Here. It's just scanl plus of x, y's, right? Almost. Does scanl not? Okay, let's go look back at the type. Okay. Scans. Scanl returns... This is what I want, isn't it? Okay, so what's it actually saying in the error message? Oh, x cons to list of y's. I think. Probable cause combines applied to too few arguments, you think. Doesn't seem right. Combine still very clearly takes two arguments. Oh, I need to... This needs an argument. Ah, okay, right. X goes here. It's my initial value. And then I can just pass y's, right? Yes. Oh, let's put back the const 0 there so we're not hamstrung by part 2 not running successfully. Getting a little nervous that this might never finish. Is it a part 2 problem? Or did I actually break part 1 this way? That's interesting. Oh, of course. The problem is in this repeat 0 that I was using. When I was using a zip, it was fine for this list to be arbitrarily long. But now that I'm actually using it as like the thing that I scan over, it needs to be the right length. Well, how the hell do I do that, man? It's a much nicer combine. I like it here, but how do I get a list that's the right number of zeros? Well, you can still zip it with a list that's the right length, I guess. Right? Like this produces a list that is fine in a way. And we know x cons to x's, like that's the length we want plus 1 basically, right? Although isn't this even going to be wrong? Oh, yeah, it needs to be... We need to add an X to the front. No. So I was talking about, like, here. I don't know, this one's simpler. I have, let's say, as many zeros as I want here. And I was saying you can take this item and this to give you back this entire list. But we want this entire list plus another thing on the right. Right? So we have to... This one we can leave. Like if we scan L over, if we build a list that's this followed by this, does that make any sense? No, that is not a sensible list. But if we add one extra zero invisibly to the end here, then scan L plus starting here on this list extended by 1 is exactly what we want. So we only have to make the initial list of zeros the right length. Which is the length of this. So... Okay, so I think that needs to happen in extrapolate, right? Because we have repeat 0. Let's say zeros. It's kind of annoying. Over map applied to x's, where zeros... Oh, hang on. This is so stupid and I hate it. Folder F zeros. Yeah, I actually need to get the lists, I guess. Where lists is map from list x's. That's fine. Zeros is zip with const repeat 0 last lists. Types are all wrong. But the idea is get the last of the lists, non-zeros. Or I don't know, maybe all this time I could have just added the zeros back here into still or solve or something. Because it already has the right number. But we'd have to add one anyway, right? And actually we want it to be one, we want it to be the same length as the last of the lists. Yeah, so zip with is correct. The problem, of course, is that we're getting... Yeah, we're getting a list when we have a non-empty, and non-empties when we want lists. I assume non-empty has a zip width? Yeah, it does. Okay. Oops. But I actually need both zip widths in this. Okay. Data list non-empty qualified as L. Any, I guess, is more common. What are we still upset about? There's one type error left. Lists is a list of non-empties, but you thought it should be a non-empty of non-empties. Yeah, that's true. I mean, I really do just have a list. I just want preludes last this time. Well, you know, whatever. I'll say prelude.last here. Prelude.last to spell it out. Not in scope. Okay. Really? Does that not even work? Or how do people do this when they want? Okay. Well, I mean, this type checks. Is it interesting, do we think? First of all, let's... Part 1. Oh my god, come on. Part 1. Does this give me the right answer again? It does. Okay, that's good. Part 2 of the test input says 0. That's not correct. Well, did I even try to fix part 2? I don't think I did. Oh, part 2 is just const 0. Yeah, okay, sure. So I kind of think like part 2 might actually have been correct all along, but there was something wrong with distill and solve that part 1 didn't notice. 81. That's still just as wrong. Oh, fuck. Okay, so what else did I do in trying to test this? So this combined with repeat 0, I mean, is still wrong? Right? So did I actually change anything with all that mess? It's cool that I can use scanl now, I guess. Oh, this is now supposed to be technically... X cons to this, right? No. Oh, but it's not... What's the function for adding a thing to the front of a list? It's not just cons, because that takes a list. There's a function called cons, but there's also called this. So I think I don't know. I worry that this is going to be completely wrong now. Yeah, I have a completely wrong number when I added that x. Oh, man. So really? Yeah, that's I recognize that number. I know it like the back of my own hand. That other one was totally wrong. But I feel like isn't this giving you back a list that's the wrong size? It's giving you back a list that's the same size as... Oh, right. It's giving you back a list that's the same size as X's was. Which is also the same size that Y's is. Wait, how is that possible? Because they're different sizes. At the end of the list, there's a bunch of zeros. And we made sure that those zeros are just as long as... So, like, here's our visual example. We had this in our list as our last element of solve. And then we said, okay, let's make a bunch of zeros exactly as long as this and have that be the last, the initial accumulator of sorts, right? So those are the two entries at the end of the first time I call combine. 222000, right? And if we look here, what do you get with 222 and 000? You get scanl plus... Ah, right. You get one that's one longer than Y's was. Which means one longer than X's was, because they were the same length. Okay. So Y's is 000, and X was 2. So you get back 2, and then another 2 for each element in Y's. You get back 4 2's, which is what we wanted. It is the right length. So, okay, now I sort of understand why part 1 still works. Why doesn't part 2 work? I mean, it's possible I should just be using subtract instead of minus, but I don't think so. Actually, maybe I should. I should, shouldn't I? Because... Isn't this going to make things way worse? I don't know. But... What am I looking... I have... Okay, let's look again at our example here. And I'm actually looking at both windows, but I don't have an easy way to show you both of them, so you might just have to suffer a little bit here. We have... Actually, I'm not even good at doing it. I'm not good at looking at both of them myself. You can't even see my mouse unless I focus this window. Ugh, let me do some window management, I guess. Okay, that's better. Oh my gosh, what? I just minimized every window on my whole desktop somehow? Okay, I'm back. So this list is our Y's, the first time that we're calling combine. And this is X's. So we let T be 2, and H be a knit of X's. Oh, the point, I think, is that I haven't changed this combine to use the scanl approach that I used in part 1. Maybe that's the problem? Yeah, because this is now shrinking the list. Yeah. This doesn't make sense. Y's is list 3, and X's is length 3, and X's is length 3. But H is only length 2. So we're zipping a length 2 with a length 3 list, and then we're adding one element. We get a length 3 list. So whereas it should have been length 4. So I don't think this zipping approach is much good. I think I want to like use scans and reverse things. What even is the type of scan R? Is that something I could possibly want? I've never used scan R. It's the right to left dual of scan L. What does that mean though? So its type is basically the same isomorphic to the type of scan L, just the same as fold L and fold R are to each other. Just takes its arguments in different order here, but has the same type ultimately. The head of the scan R is the same as folding over it. I mean, that does actually seem like it might be what I want. Let's play around in GHCI a bit. This is all in scope, right? The type, please. Yes, so that does exist. Okay. So if it's scan R and I'm starting from the right and I have something to, it should be subtract, right? And I want to start with, what's one of the example inputs? The very first one, 15, with the deltas under it should be all 3s. So any.replicate. Oh, does that even exist? It doesn't, because you can pass 0 to replicate. 3. Nope. Of course, replicate is still going to be broken. Any dot from list of replicate. How many 3s are there in the input? 5. 3 times. 3, 6, 9. 12, 15. Yes, this reproduces the original list. And we just need to get it to go a little bit further by giving it 6 3s. And it'll say, I would have started with 0. Wait a minute, it actually did start with 0. I just typed it in wrong. Hang on, what? So I'm looking at this input. These are the inputs we got. And if I give it 6 3s, shouldn't it start here, subtract 3, shouldn't it subtract 3 5 times? If you give it 5 things, it should yield a list of length 6. Oh, I missed it. There it is. There's a -3. I was just looking at the list. I thought this was some GHCI punctuation. Okay, so it actually does give you back... Yeah, great. So I think that is sort of what I want. I want to scan R... subtract the last, starting at the last element of x's over y's, and I think that's it. Is that type check? Yes. I think that makes sense. So if I reload this and say part 2, it still says fucking 81. God damn it. It's supposed to be like 3, man. 2. It's supposed to be 2. Or no. 2 and 5 and 0. So it should be 7. How am I so bad? Okay. Did I do any other cool experiments with part 2 at some point? No. Part 2 of the test input, right, is, if I look at the very simplest test input, it was just 0, 3 up to 15, right? Of 0, 3, 15. What type does part 2 want? Oh, it wants pure, I see. Yeah, that says 15, which is way wrong. It should be -3, shouldn't it? It should be. So what are x's and y's when we get here? They should be a few 3s, no, a few 2s. Or wait, I've forgotten which one is the input list. So there should be a few 3s and then a few 0s. And there should be like 5 of each. So, I hate to do it, but let's import debug.trace, I guess. And I think I'll just use trace instead of like trace showid or whatever, or trace show, because I want to write a few things here. In our combine, we want to write trace x's actually, I think I do kind of want trace show, don't I? What is the type of that again? Trace show. No, search Google, please. Trace show. An A, a B, and a B. Yeah, this isn't really what I want. Okay, that's fine. X's, Y's equal show of X's, Y's and then actually return this. What is the type of trace? A string, an A, and an A. Trace? Right, I always forget you're going to need parentheses around this. It always seems like the $sign should work, but it doesn't. Because there's operators inside of this, the string you're building. Okay. So if I say now reload and run this again, doesn't trace show anything? Oh, that's because I put this in the part 1 thing. And I can get rid of that. Yeah, so, okay. It's a list. The first time it's called, at the end of the list, we have 5 zeros and 5 threes to combine. And that's wrong somehow. Combine. What type does combine take? These inputs are all unnecessary, huh? Well, that's something for the scanl approach, I guess. Oh, okay. Combine. Okay, it just takes a non-empty. Okay, right. It just takes 2 non-empties events and returns another. So let's finally give that a type, I guess. I mean, it's just this. Maybe we should extract that as a type synonym, but probably not. Right? So now the reason I wanted to know that is because I wanted to write combine of the things that it gives me here. Combine of this, our x's, and this, our y's. It's a list of 6 threes. Well, I could have told you that. First of all, it's correct because that's what it should have been. But also, we could have known that because that's what y's is here. So, combine of... Oh my god! I think the problem is I'm just calling last instead of first at the end when I'm in running part 2. I think this is actually... Okay. Let's just check, though. Hello? I can't paste? Oh, I pasted too many times. I should use tmux to do it, not my mouse. So, paste. Okay, combine... Like that? Yeah, it's a -3 at the front of the list. Oh, man. How long has this code been correct and I just forgot to do with the result? What to do with the results? What is the sum of the extrapolated values? Those are the ones at the front of the list. Oh my god. Okay. The problem is that combine is what's actually calling last. Okay, so the issue is the fact that part of part 1 was baked into combine was sort of lost on me. So I think I will just do this. Returns a list event. We'll say last. Of course, that's the one from Prelude. Okay, but let's... I really think that importing anything from data list not empty without qualifying it is kind of setting yourself up to fail. Last. So let's just call preludes last here. And then down here we'll call non-empties last. Okay. Where are we still upset here? Oh, well... I guess it actually returns a non-empty event, right? Technically? Yeah, and then... there we want any, and here we want any. Okay, now it all compiles. I think we can get rid of this trace, because actually the function is working just fine. Stack run. Seems low. Well, I guess what we should do before any of this, really, is just test that, yeah, part 2 returns 2, and I believe that's what it's supposed to be, right? Yeah, 5 minus 3 and 0, that's 2. Okay. So I think this might actually be the right answer. Let's find out. Oh, I spent forever debugging this stupid garbage because there was a call to last hiding somewhere that I wasn't looking, that I had, like, forgotten about. I computed the right lists, and I think I must have had them quite some time ago. And the call to last was just hidden. Gross. Okay. Well, let's inline this to part 2 again. I mean, it's kind of nice, I think, the way this is structured, right? X's, Y's equal ne.scanl plus of ne.tail. No. ne.head X's and then Y's, right? This is still correct? Yes. Okay, that's kind of nice. Head is something you don't want to use, but non-empty's head is fine. And you'd like to prefer pattern matching over calling a function because it lets you get all of the value, but in this case I only want some of it. And there's some nice symmetry here. Now I need to go fix up this horrific Every single one of these I want to get rid of the weird import. Repeat is already handled. From list, I actually do kind of need that, but I think I'll use it qualified. Scanl. Yeah, this is already imported or used qualified. And I don't think I'm using the constructors either. So really all I want is the type. And then, of course, the rest of it qualified. So this is looking a bit better now, I think. You could try to like factor out part one's sum and map and extrapolate, combine, and solve, right? Like, but so the part one and part two could just delegate to another function, but it would have holes in it for any.head and combine. Like, it's fine. I'm gonna leave it alone. Okay, let's make sure it still produces the right answer after my little surgery there. Yes, okay. How bad is the damage here? What monstrosity have I written for part two? I guess I'll take it. Day 9, part 2. Yuck. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.